Exercise 4B, question 3. Okay, so we are starting with another standard expansion, but we are this time going up to x squared. So as usual, let's write the question down. 4 minus x all square rooted. Turn it into index form to the half. Right, quick check. That is not a 1, so we are going to need to factorise. Always check. It's so easy to get carried away in an exam and forget to check. So I'm going to bring the 4 out. It also has the power, incredibly important, and I've got 1 minus x over 4 to the half left inside. Okay, so as 4 to the half is simply 2, I'm going to simplify that to 2. Open brackets. Right, everywhere I see x, I'm going to put minus x over 4, and everywhere I need my n, that's going to be a half. Okay, so 1 plus n x plus, all right, so I've got a n minus 1. Let's not lose the minus on that. Over 2 minus x over 4 squared plus, don't need more, which is great news. Sorry. So let's work this out. So 2 minus 8 minus x squared over 128. So I'm sticking all those fractions in my calculator. Times it out, and I'm going to get 2 minus x over 4 minus x squared over 64. Okay, so now I've got that, I am on to part B. Now, part B is a show that when x equals a ninth, the exact value of mx. Now, it's talking about mx here, which is my square root of 4 minus x. So I am going to put 1/9 into mx. So m of 1/9, because x is a ninth, is, now be careful, this is asking me to put it in the square root of 4 minus x. It is not asking me to put it in the expansion. Mx is the original function in the question. Now, it's a show that, so I'm going to do this carefully. So 4 minus a ninth is 35 over 9. You can do it in your head or in a calculator, that bit. Now, remember, this is a show that, so I'm going to do it slow and steady, no jumping to the answer. I'm going to really make it pedantic. On a show that, it is your job to convince the marker that you have got there and would have got there without knowing what the answer is. So be careful on show that exam questions. They are very, you've got to be convincing. You do not get benefit of the doubt. It's your job to be convinced, or to convince the marker, I should say. Right, here's your answer to find approximately 35. Now, if I put 1/9 into m, I have just worked out that I get root 35 over 3. Okay, so root 35 over 3 is what I get if I put 1/9 into the function. So that is what will be approximately equal to what happens when I put 1/9 into the expansion for that function. Oh, sorry, let's get rid of that x. That should be 1/9. Okay, now if I stick that in the calculator, I get 1.972029. I'm working to 6 decimal places. If you're not sure, just work to quite a decent number and you should be safe. Right, so what you've got here, and you have to look quite carefully what you've written. I have written that root 35 over 3 is approximately equal to that. So putting 1/9 in did not tell me root 35. It told me root 35 over 3, and this is a very standard exam style question. So how can I get an estimate for what root 35 is approximately using the expansion? Well, I will just take 1.972029 and times it by 3 to get 5.916088. Okay, and at this point you should be thinking, what is root 35? Well, it is something just under 6, root 36 being 6. So this is looking good. Always think about your answer. Is it in the right ballpark? Okay. Very rarely will you stick x's value in and it will give you exactly what you're looking for. Often it will give you a multiple or a fraction of what you're looking for, like it did in this case. Right, percentage error. Predicted 916088 minus actual, which I calculated to be 5.91608, although you could just put 35 in, of course, over actual 5.91608. Was it by 100? And I got 1.35 times 10 to the minus 4%. You can see just how accurate that is. I only went up to x squared, but I managed to get a really accurate estimate. The power of this is technically, if you had good mental arithmetic skills, you could potentially get, at least in fractional form, an estimate for root 35 that is incredibly accurate, and square rooting is a difficult computational calculation otherwise. Okay, the book has 1.38, I believe, because they went to 5 decimal places rather than 6 decimal places. But obviously, with a reasonable degree of accuracy evidenced, you would get marks.